Okay, we're going to go over the Stats Chapter 8 and 9 practice quiz. The question is, the average movie ticket prices in selected years since 1948 are listed in the table below. Here's the years, which will be our X. Here's the movie ticket prices, which will be our Y. And it says to create a linear model for this data. So I've already typed in the numbers onto our calculator. To find a linear model, we have to ensure, let's see, stat diagnostics is turned on. We're going to go to our stat, calculate. Down here, linear regression a plus bx. Okay, we have our X list, which is our year, our Y list, which is going to be our price. Calculate. So our linear model for the data is y equals a plus bx, just like the model there. Our y value is a movie ticket price. So I'm just going to list the price. And I'll put the little roof on it, the arrow on top, to show that it's the predicted price. And that's going to equal our a plus bx. Our a value is here. So we'll put negative 190. Let's do about 4 decimal places here. So 0.2427. 2427. And then it says positive b, so plus 0.097. Let's go ahead and make that a 5. And then times our x value, which is the year. Now, in my table, I made no changes to my year. Notice the year starts at 1948, like it starts here. If I made this equal to 0, I would say this is the year or years after 1948. Like that would be 0, that would be 4, that would be 10, that would be, what, 15. In my table I didn't do that, so I didn't do that for my equation here. Okay, next it says discuss the accuracy of this data. So if I was to do a stat plot and look at the graph of this, you should notice, okay, the X list is the year, the Y list is the price. I'm going to go ahead and make this little plus signs and it's a dot. If I zoom stat, I get a curve, okay? So although the scatter plot's strong, okay, it's curved, so linear model is not accurate, and we're going to make a little graph to show that. So let's start by discussing the accuracy of this graph. We're going to say, although the scatter plot is strong, it is curved. So a linear model is inaccurate. Okay. Now I'm going to make a little note here that says, see graph 1. And let's sketch this somewhere to show what we're talking about. So I'm going to, since this doesn't really have any space, I'm going to turn the page over. I'm going to call this graph 1. Okay. So the title is Year and Movie Ticket Price. And I'm going to create let's do an X and Y. So this is the year, and this is the price. So I'm going to go to my window, and I'm going to start at, let's say, 1940, go to the year 2000, whoops, counting by 20s. And then my X values are going to start at, let's say, 0. Let's go to $5, just counting by $1. Let's graph that. So once again, the year started at 1940. It went 1940, 1960, 1980, all the way to the year 2000. And the price went from $0 up to $1, $2, $3, $4, $5. Okay. So I'm just going to make a little sketch here, and it can be helpful to trace it. Okay, push the trace button. So it says here my x value is 1948 is about 0.36, so 1948, 0.36, probably something about there. Okay, I'm just going to kind of make some selected points. So at 1971, about here is about $1.65. So there's a few dots in the middle there. And then it's going to keep going up all the way to the last number here, which is 1988, up to about 411. So about here. So a big grouping of numbers to kind of create that curve there. Okay. All right. So although the scatter plot is strong, it is curved, so linear model is inaccurate. See graph 1. The next question is to create a strong predictive model. So at this point, we want to straighten out or re-express our data. So going down the list, there's a few things we want to look at. I'm thinking of things like squaring all of our numbers. We're going to skip the first power. We know that's not going to work. We're going to try doing a radical power and then go to a log power. If that doesn't work, I'll try taking the negative radical, okay, or the reciprocal of the radical, or possibly the reciprocal function. So I'm going to go down my ladder, skipping 1 because that's just the first power, and the 0 is the log function. So let's see what happens when we square all of our numbers. So go to my list, go to my y value price, square all of them. Okay. I want to store my numbers. So down here is the store button. I'm going to store all of those numbers as the list 1. Okay, second 1. When I look at that graph, change the y value to my L1. When I look at that graph, it's still a curve. So I don't really want to do the squared. Okay, the squared re-expression, that wouldn't really help me out. I'm trying to find a line. So let's go back and let's square root our function. So let's take the square root of our function. Okay, going back to the original y value, our price. Let's store that as L2. Okay, let's look at that graph. Okay, so zoom, stat. It looks kind of like a line. So I'm going to put a little question mark here saying it looks pretty good. Maybe that's the one that looks the best. Let's go on to the next one, which is the log function. So let's take the log. Let's clear that out. Let's take the log of our list, of our original y, our original price list. And let's see what that looks like. So let's store that as L3. Let's look at the stat plot of our L3. To me, that looks much straighter than the last one. I don't really think it's going to get much straighter than that. So let's go ahead and let's just do the log graph. So that would be the log of our y value, of our predicted price. That's going to equal our a plus bx. Our a plus bx, we don't know what it is yet. So go to our stat, calculate, linear regression. So our a plus bx line. Our price, we're going to change to that L3. Remember, this was a L1, that was L2. This is our L3, our list 3. So we're going to put that for our y list for our a plus bx line. Go down here to calculate it. Let's see what comes up. So we have negative 52.8296. Let's call that 97. And then a positive b, so 0.02689. 2689. And that's being multiplied by our year. So that would be the stronger predictive model, because that's going to give us, I think, a pretty strong looking line. So explain why your new model is better. Well, taking the logarithm of the price, straighten the line. So that's simply why it's better. Okay? Taking the logarithm of the y value of the price and we're going to say C graph 2. Okay? So once again, explain why your new model is better. Taking the logarithm of the price, straighten the line. Okay? Or, because the first one, the reason why it didn't work, even though it had a strong association, it had a curved line. So the reason why this one is better is because it's a straight line, and we want a linear model. So let's make a graph 2. Let's call that 1 like that. Let's take a look at graph number 2. Now this one is also year and movie ticket price. Let's make our L again. So I want to graph this. Whoops. Our x-axis was the year. Our y-axis was the logarithm of the price, or the log of the price. So let's take a look at our window. The x value, let's do 1940 to 2000 again, counting by 20 years at a time. The x the y min and max, that's kind of arbitrary looking. Let's go make that -1 to +1, counting by halves. So if I just graph that, that goes from 1940 to the year 2000. So that'll be consistent. And then up and down, this is going to be our 0. This is -1, that's +1. Right in the middle will be 1/2. Right in the middle there will be -1/2. And just making some little dash marks in there. This looks something like something like this. And we can make the dots darker. Okay. Where this one's supposed to show a curve, this one's supposed to show a line. So let's go through the questions again. Create a linear model for this data. We did, but it wasn't very accurate because it didn't create a line, it created a curve. Create a stronger predictive model. So we did so by trial and error, and we found that the log of the y value gave us a pretty straight line of our data, and that's just why it's better, because by taking the logarithm of the price, it straightened the line. And we graphed each one to kind of show our evidence and make sure we have our labels. Okay, lastly on here, assess how well your model would work for someone wanting to analyze movie ticket pricing. So we want to make an assessment, and we're feeling like it's a really good model, right? So looking at our data, looking at our a plus bx on our calculator, and we calculate it. Once again, L3 was our logarithm data. Our R, which is the strength of our association, gets a correlation coefficient, is almost 1, and our R squared is over 99%. So we're going to say the model, I'm going to zoom in right here. The model explains 99.6%. Okay, I took this number, R squared, 99.58, or 0.9958, and I rounded that as a percentage to be 99.6. So that's where I got that number from. That's my R squared. The model explains 99.6% of the variability of the variability in ticket pricing and has a residual plot Oh, that was one thing we didn't check. We forgot to check. Our residual plot. So because I calculated that, my residual plot should be active. Okay, to get the residual plot, you have to make sure you hit the stat, calculate. Okay, you got to do that before you can do a residual plot. It won't be available to you. So go down to my residual plot for my y value. Zoom, stat. As you see, my residual plot is a mess. Okay, there's not really any pattern to it. If I was to put another point on there, I'd have, I mean, it might be over here, might be over there, might be. There's not really a true pattern. So I apologize for not showing that earlier, but you got to speak about the residual plot in this question. Okay, asking about analyzing and assessing the model. So, and has a residual plot with no pattern, and has a residual plot Okay, the model based on a logarithmic re-expression is the best model and should be fairly accurate based on the high value of r squared. So we want to kind of state that the logarithmic re-expression was the best one. Okay, that it should be pretty accurate, and we feel pretty confident because it has a high r squared number. So the model based on a logarithmic re-expression is the best model and should be fairly accurate based on the high value of r squared. Based on the high value of r squared. And usually when we write r squared, we make it a capital R. Okay. So let's go through the questions again. We're given a table of average movie ticket prices that were selected from the years 1948 and their average movie price during that year. So we created a linear model, not doing any re-expressions, just doing the model by plugging the data into the calculator. Okay, year, price. Pushing stat, going to calculate, all the way down to number 8, the linear regression, a plus bx. Putting the year for our x value, movie ticket for our y value. called price, calculating that, and our linear model is simply our predicted y equals a plus bx. Our predicted price equals this number plus that number. The accuracy, it's inaccurate because it creates a curve. Okay. So to make it stronger, we tried a few things and we found that the logarithm was the best way to straighten the graph. Okay. When we did the logarithm, of our price, and we ended up saving it as the third list, when we graphed it, it gave us a pretty straight looking line. Oh, did I make a mistake on that one? I think I may have. Oh, I did. That should not be here. That should be price. So logarithm of our price list, saved it as L3. So to add our stat plot, redo that. There we go. Goes across the 0. So we notice it's a pretty straight line, and it kind of tells us that with our a plus bx, it tells us that it's our R value, our correlation coefficient, is almost 1. So our accuracy is over 99%. So that's why we use this one as our new model. Explain why it's better. Well, it's simply better because it straightened the line. On our assessment, this model explains 99.6% of the variability in ticket pricing and has a residuals plot with no pattern. Okay. To find the residuals plot, I ensure that I make the linear regression of what I want the residuals of. After I've done this calculation, I go to my stat plot. I change the y value to the residuals list, which comes from the list. Okay, I zoom stat it, and we notice it's pretty well scattered. So the residuals plot has no pattern. The model based on the logarithmic re-expression is the best model and should be fairly accurate based on the high value of r squared. So that's like our little summary statement there. Okay. Any questions, please email me or ask me during class time.